So here in this problem, we are told a box is being pulled up an incline. Pulled up an incline. The force is parallel to the incline. We've got normal, we've got gravity, we've got friction. We know the incline is at an angle of 25 degrees. We're told our sort of displacement, d is 2 meters, and mu of k is 0.2. We have a mass, 5 kilograms, just a few random variables. We may not need all of them. So let's look, how much work is done by gravity? Well, we know that the work done by gravity is equivalent to the force of gravity times the distance of displacement times cosine theta. So let's look at this. Let's see, Wg equals Fg. What is the force of gravity? Well, it is this sort of Fg here, and it's mass times gravity, mg, times the distance d times cosine of theta. And so we can plug in a few numbers, 5 kilograms times 9.8 times 2 meters times cosine. And what's our theta? Remember, theta is the angle between the force or the force here is down, straight down. Force of gravity, the angle between the force and the distance, and our distance is d, up the ramp. So the angle between them is sort of this whole way, right there, right? And how do we find that angle? Well, we can find this angle. We're just doing a little bit of geometry here. To be 90 minus 25, kind of like adding up the angles in the triangle. They should all add up to 180. And so we find that this is 65 degrees. And understanding that this 65 and this is our theta here. This needs to add up to 180. And so this becomes 95 degrees. Sorry, needs to add up to 180. So it's 115. We'll make that add up to 180. So we found our theta to be 115 degrees. We're just doing geometry so we can find the angle between the force and the displacement. And we can plug that into a calculator. And we're going to get negative 41. And the units are joules. And we got a negative, right? Because the work done was negative. It was sort of, gravity took away some energy. We had to put extra energy in to overcome gravity. We expect the work done by gravity to be negative. So that answers part A. Then we have how much energy is lost because of friction. When we look at the work because of friction, is the force of friction times displacement times cosine theta. And you can set up your net force equations. All right, we're going to do a free body diagram. We're going to pick our new x and y coordinate axes for our free body diagram. This is the force of gravity. This is friction. This is the normal force. This is the push. You can set up your net force equations. You can solve for the force of friction. And I will leave that to you guys. But we have our distance d, which is 2, times cosine. And what's our theta? Well, our theta is 180 degrees. And we're going to end up getting, well, cosine 180 is negative 1. So we're going to end up getting a negative work. And once again, friction is sort of a loss, right? It's not putting energy in, it's taking energy away. So we expect it to be negative. That's how you can find your friction work. We have to see how much work is done by the 50 Newton force. Well, work is the push times the distance times cosine theta. And the push is 50 newtons times 2 meters times, well, the cosine of the angle between them, they both point in the same direction. So the angle between them is 0. And so our work done here is just 100 joules. It's just the force times distance, since they point in the same direction. And we can find our work done by the force. Part D asks us for the change in the kinetic energy of the box. just like in the last question, the kinetic energy is the work net. The net energy we put in. And remember that the net work is the work done by gravity, plus the work done by the normal force, plus the work done by friction, plus the work done by the push, right? We add up all the work done. That tells us the net effect, and we can find our kinetic energy. And then it asks, what is the speed of the box after it has been pulled 2 meters? Well, we know KE. We found it. Found some KE in joules. And we also know that KE is equal to 1/2 mv squared. Or we can rewrite this to be V equals the square root of KE times 2 over mass. We can plug in what we know. We know what the kinetic energy is. We know the mass. We can calculate a speed.